Welcome to our episode of Biblical Archaeology from the Ground Down. Sponsored by Bible Interact and hosted by Dr. George Sparks. Now let's explore the field of archaeology in today's episode.
Is the Shroud of Turin the burial cloth of Christ or a medieval relic? Today with us is Mr. Hugh Farey, a prominent researcher and former editor of the British Society for the Turin Shroud Study. Hugh has also completed courses in shroud study in Rome. Although Catholic, he has remained skeptic of the shroud's authenticity, arguing, number one, its medieval provenance, and number two, artistic creation, but within a scientific critique. Welcome to our program, Mr. Hugh Farey.
Okay, a bit of radiocarbon dating 101 to start with, and then we'll get into a bit of the nitty-gritty later on, and you'll see why. So here's the shroud, and here's a graph, and the important thing is the horizontal pink line across the top. You see the horizontal pink line across the top?
Yes.
That is what I'm assuming is the level of radiocarbon in the atmosphere, more or less constant, more or less continuous, and I've got it going from the year 2000, which is us, more or less, on the left-hand side, going down to 200 BC on the right-hand side. And as the proportion of radiocarbon in the atmosphere in 1950 is considered 100%, that's the figure that's given to it, which is why the sloping pink line starts off high up there where it says 100. And then as we get older and older and older, we get less and less and less radiocarbon until when we get down to 200 BC, it's about 77%. Can we see that?
Mm-hmm. Yes.
Yeah. And this was Willard Libby's great discovery in the 1950s.
Right.
However, he very soon found, and he found it himself, so it wasn't too much of a surprise, that the pink line across the top was a mistake. The amount of radiocarbon in the atmosphere has not been constant at all. It varies, and it varies by quite a lot. Can you see now? I've turned the pink line into a green line.
Mm-hmm.
Can you see that?
Yes.
And this is how the radiocarbon in the atmosphere has varied. Sometimes it's been a lot more than what it is now, which is roughly the straight pink line. And from about 1300 down to about 200 BC, it's been a bit less than what it is now. And this means that if the pink line, which is how much radiocarbon is left, wiggles around in exactly the same style as the green line on the top. Now, in order to get it right, what we do is we use dendrochronology. And this has been absolutely fascinating in that, can you see how the tree rings there have been started off on the right-hand side? We're going from right to left in this rather Arabic style. A modern tree, you can just cut down and count the rings. And then when you get some old buildings, you can take a core or look at a plank and find out that one end of the plank, the tree rings there exactly match, rather like a barcode, modern tree rings. And so from various historical objects, like the back of pictures, where pictures have been painted on wood, or logs in ancient dwellings, right down to bits of fossil trees sticking out of the bank, we can get these tree rings and match them up as they are, where you can see those sections of overlap there. And that means that we can get a succession of tree rings, and we know exactly to the nearest year when each of those tree rings was formed.
Now,
And then we can, sorry, yeah?
Hugh, I have read that sometimes a tree will grow 2 rings in 1 year. And so that can throw the whole
just to
population
get-
off.
Well, it does, but only by 1 year.
Right.
So, and that might happen 50 times, but it's not going to make a lot of difference in the great scheme of things.
Okay.
Also, of course, if we work out that year has had, I don't know whether dendrochronologists can do that and say these 2 rings represent 1 year's growth, then of course they can account for it.
Mm-hmm.
Anyway, the point is what you can then scoop out, which we couldn't do in days when you needed, I don't know, a gram of material. But now that you've got AMS dating, we can take out a minute piece of wood just from that ring and find out what proportion of radiocarbon corresponds to that ring, which means that your pink line going, the pink line now, can you see, is not an accurate rendition of the age of things, because we have to compare the proportion of radiocarbon with the green line, not with the pink line. Do you see what I mean?
Yes.
And I'll give you an example. If you start on the left-hand side with 96% and drop that down according to, slide it along till you meet the pink line and drop it down, you might think that you had discovered an artifact from 1620 or so. But in fact, you really need to follow it along till you get to the green line, go from 96, go right, follow the line right until you get to the green line and drop it down there. And you discover that instead of 1510, the artifact actually comes from 1450. So it's 250 years earlier than what you originally thought. Do you see what I mean?
Yeah.
Yes.
I can see George looking confused, but surely you know.
No,
Yes?
I got two screens going on here. Yes, I'm fine.
Yeah. Okay. Whereas if we take, say, let's take another one down the bottom here. If we take something like 88%, if I start with my finger on the 88% line on the left-hand side and slide it along, I get to a spot where the green and the pink lines coincide. So if I get 88%, I can be fairly sure that my artifact was from round about 860 or so. Now, the shroud, as you know, the little piece of shroud that was used for radiocarbon dating was taken from, on my picture here, the bottom left-hand corner. In fact, you can see a little pale tower block on the bottom left-hand corner of the shroud of my slide, and the right-hand side of that is the space left where the radiocarbon sample was taken. So they took that and they ran it through their AMS radiocarbon dating machines. And this is something that people don't understand, I think, as well. And that is that the radiocarbon dating machines don't give you a date, because they can't. All they can do is measure proportions of radiocarbon. Each lab got a little sample, they chopped them into different pieces and dated some of their pieces. The Arizona lab dated 4 pieces, the Oxford lab dated 3 pieces, and the Zurich lab dated 5 pieces, and each one came up with a particular percentage of radiocarbon. Now, nowadays, what you could do is take that percentage of radiocarbon, run it along to the green line, and see what it comes up with. Here they are. This is A. The Arizona samples are labeled A, the Zurich samples are labeled Z, the Oxford samples labeled O, and you can see that I've arranged them not as all the Arizonas, the Oxfords, and the Zurichs together, but with the sample which had the most radiocarbon in it, which was one of the Arizona samples, 93%, and the sample with the least radiocarbon in it, that's the Oxford sample at the bottom, which had about 91%. Now, when radiocarbon was formulated, they didn't know much about the calibration curve. So instead of converting the radiocarbon straight into a calendar date, you transferred it by means of a simple chemical equation into a date before present,
DP, yep.
which will give you, as you can see, around about 500, 600, 700 years before present. But that only matches the purple line, the smooth, uncalibrated line. And from that, you can get an approximate calendar date, and the year 1359 at the top, approximate calendar date represented by the purple line on the previous graph, and the actual calendar date represented by the green line on the previous graph are much the same, 1359 or 1357. When we get down to the bottom Oxford sample, where there's only 90% of the modern radiocarbon, we can see that if we followed the purple line, we would say that the shroud was dated from about 1155. But if we use the actual calibration line, it comes from 1214, which is 75 years later, which is much more precise and much more accurate. Here then are all those proportions slapped straight across into the, what I've called the green line, but it's now gone blue for some reason. And these then are the dates that have been put together from the radiocarbon, and I've gone directly here from proportion of radiocarbon to calendar years. And the real point is not so much the exact details of this, but look where the horizontal blue bar would have to be if the shroud dated from the 1st century. As you can see, we'd be looking at something like 77 to 79% of modern radiocarbon in the cloth. Whereas every single sample of the 12 little subsamples that were tested were all more than 90% modern radiocarbon. So that not one of them could possibly have been down amongst the 1st century.
Now, Hugh.
Now I'm getting even more. Sorry?
Now, my logic would say, and I'm not just trying to argue from a particular perspective here, but my logic would say that those dates certainly probably accurate in the sense that there's some miscalculation there, but the piece of cloth that was sampled was the one that was used for the repair, and thus it was repaired later. And so the dates could be correct, but it doesn't necessarily date the cloth of the shroud. Am I missing something there?
No, you're absolutely right. I'm assuming for the time being that the dates were taken from a piece of shroud that was consistent with the rest of the shroud. But we'll come to the objections to it later on. Okay. Now I'm going to get really pernickety here, which is again involved turning this graph upside down and inside out, because the way that the calendar years are really calibrated nearly always today is using a program that was written, I think, and certainly maintained by Christopher Ramsay, who's the head of the Oxford Radiocarbon Unit, who was one of the signatories to the 1988 Nature paper on radiocarbon dating. So if you go onto this thing, you can see at the top there, it's called OxCal version 4.4.4 Bronk Ramsay 2021. This is the date. If I put in the date which corresponded to 795 years BP with a 65-year error, you can see that that's represented by that big red curve on the left-hand side, and then my two green lines at the top and the bottom of that curve slided across to the blue wiggly curve running diagonally, and that more or less coincides with those that black range of mountains which you can see underneath. Can you see the black range of mountains?
Mm-hmm.
And that, the computer will tell you, shows you that there is a 5.1% chance that this bit of shroud dated from 1046 to 1084. And that's because the red parabolic curve actually hits a little piece, a kink in the blue wiggly line, which descends downwards. And then there's a tiny chance, a 0.5% chance that it dates from a little further on, and then quite a big chance that it dates from between 1124 and 1304, and a very small chance that it dates from 1367 to 1381. And that's how so all the green bits are put in by me, but the red and blue and black bits are directly taken off OxCal, the calculator for working out the calendar date from the radiocarbon date BP. The reason I did this is because I then merged, this is the one with the least radiocarbon left behind, and now I'm going to add to it the little sample which had the most radiocarbon left behind. So I've taken out the green lines, and now you can see I've combined the whole thing, and this is both sections, and we can see interestingly that they overlap, and we've got a remote possibility that the shroud might date from 1020-ish, right through to, and this was quoted in the Nature paper, to about 1420-ish. Well, of course, we know that it can't date from 1420 because by that time it had been exhibited twice. So the green line gives us our terminus antiquem, or the date before which it must be dated. And we can see that there is an overwhelming possibility, just looking at the biggest pile of mountain, that it's around about 1250 to 1300. Interestingly, we find later on that there's very little possibility of it actually appearing exactly where I've put my green line. So it must have been made before it was first exhibited, but that's not too much of a surprise. So the point is that every single one of the possible radiocarbon dates actually conform to a reasonably accurate area of time range. However, very few people have investigated it using the calendar dates. Usually they use what's called the BP, the before present dates, and this is where we find that some of the dates don't match as well as statistically as well as they ought to. Now, let's have a look at the shroud itself, picture taken in 1978 by Vernon Miller, and that blue mark on it, top left-hand corner, is where the samples were taken from. And it's important to realize that you cannot see any patching at all, even under very high magnification. But under very high magnification, we can see, and so could John Jackson, who commented on it, we can see the weave of the shroud is exactly the same all the way through all of that, all of those little blue patches. So there is no obvious patching at all. There's no extra bit of cloth which has been substituted. It's not at all like the big patches which are found all over the shroud, which is where the poor Clare nuns put on, literally stitched on some patches like you might patch a pair of jeans because of the holes that were made by the fire. Now, there's enormous excitement amongst the authenticist community who don't really understand statistics, because they say that it was very wrong of the British Museum not to notice that there was a chronological gradient, that the Arizona area was much younger, that the Zurich area was of a middle age, and the Oxford area was much older. But at the time, nobody knew which of those three little squares that I've chopped off the right-hand edge of the sample in the top left-hand corner there, nobody knew in what order they came. So they could have been Arizona young, Oxford old, Zurich. It could have gone in the order Arizona, Oxford, Zurich, or Arizona, Zurich, Oxford, or Oxford, Arizona, Zurich. There were 6 possible ways in which the dates could be arranged, and only 2 of them show any kind of gradient. Now, we know, because we've examined the little photographs of the original samples quite well, we now know that the Oxford is the section on the left-hand side of the sample, then comes Zurich, then comes Arizona. You can see if you look at the sample that I've drawn, the little blue sample, that the Arizona sample on the far right-hand side is a little bit smaller than the Zurich sample in the middle and the Oxford sample next to it. The sort of pistol holster shaped bit on the left-hand side was what they called the reservoir, which is still kept in Turin today. But in order to give Arizona exactly the right amount as the others, they trimmed a little section off the reservoir to add to the Arizona section, so that all the labs got more or less exactly 50 milligrams of cloth. Now, as you can see, there's no patching. So it was originally Joe Marino's idea that possibly a patch had been sewn on, but there's absolutely no sign of patching, we've now decided that it's not that. Just supposing that area, which I've accentuated the contrast and it's quite a dark brown, let's suppose that area was so threadbare for one reason or another that it meant the shroud was coming to pieces, and that at some point quite early in the 16th century they decided to repair it, not by sticking a patch on, but by actually replicating the weave with some new cloth. And that would mean that the new cloth would be indetectable from the old cloth, and that would mean, as David suggested, that when you tested a piece of cloth, you got a mixture of 16th century cloth and 1st century cloth. And of course, without knowing the difference, you burn your stuff, you run it through the machine, and it comes up with a date. Now, there's various problems with that. The first is that in order to produce a date shifted by 1500 years, about 3/4 of the cloth would have been repair, and only 1/4 would have been original. And that is not detectable under a microscope. It wasn't detectable when Timothy Jull carefully looked at the little piece that one of the little pieces that Arizona had left over, and it wasn't detectable when Mechtilde Thury-Lomberg replaced the backing cloth in 2002. There's absolutely no evidence of any reweave at all. Well, if you read any of Joe Marino's later works, he says, but there was a technique called French invisible reweaving, when you could exactly copy the weave so perfectly that the mend would be completely invisible. But this isn't true. He derives his idea that it is invisible from a book which was very popular in the United States in about the 60s called French Invisible Reweaving, and it was a kind of franchise. You could buy the book and some tools, I say online, no, by mail order, and set yourself up in a little business of invisible reweaving. And it was a way of mending quite expensive clothes, which perhaps a favorite jacket or something like that, which had a hole in it. And you could mend it mostly by using threads which you extracted from the hem of the jacket. And by exactly matching the weave, you could produce a mend which looked almost undetectable, but only from one side. From the other side, it's very clearly detectable, especially if you look at it under a microscope. And well, we had a bit of an argument about this, because some people said, no, I've got a book which says it's invisible. And I said, well, I don't think it is invisible. So eventually I got a piece of cloth, burnt a hole in it, and sent it to the two leading French invisible menders in the world. One is a firm called Without a Trace in Chicago, and the other is a firm called British Invisible Mending, I think, in London. An enormous expense. They sent me these little bits of cloth back with their mends, and of course they were visible. Because when you're threading new threads through old threads, there is always a place at which the two threads overlap. The other thing is that people have noticed, as indeed, now that I've emphasized the contrast, you'll notice yourself, that about 1/2 of the samples is a much darker color than the other half. The top half looks, on this photo here, looks very dark brown compared to sort of pale brown of the other sample. And the Oxford sample is darker than all of them. The Oxford sample is the one with the crease running through it. And somebody said, well, we've carried out lots of complicated calculations and determined exactly that there is a 99.9% correlation between the date of the shroud and the color of the sample. And this was from the St. Louis conference, which was in 2014, was it? And everyone said, well, there you go. That just proves it. The contamination exactly correlates with the age discovered by the radiocarbon labs. Therefore, they must be responsible for it. But what they didn't notice was that if that's the case, the contamination makes the shroud much, much older, not much, much younger. And this, of course, has completely thrown the contamination idea out of the water. Because if the contamination was put into the shroud after the shroud was made after the 1st century, it should make the shroud look much younger. But it doesn't. It makes the shroud look older. If you look at the middle little chart, which I've got there, the lower of the two green bands, we've got Oxford on the left-hand side is old, even though it's the most heavily contaminated. Zurich is medium, and Arizona appears young, even though it's not heavily contaminated. This suggests that contamination has nothing whatever to do with it. And in fact, way back in 1984, when the Shroud of Turin research project was planning on taking their sample from exactly this spot, they said that they realized there was contamination there, but they didn't think it would make any difference. And indeed, they were absolutely right, as I think you can see. Now, sorry, yeah?
I want to push back on that because as an archaeologist who actually works in the field, my job actually at Qumran was the Register of Finds, and I had to process everything. I had to be very careful in how I handled that particular piece of textile so as I did not contaminate it and throw the dates off. Now, the fact that this has been piece of cloth has been handled in the medieval period by those that were displaying it and holding it, they would have contaminated it.
Oh, yeah. But they did. You can see contamination.
And thus creating an older date, not being the date of the...
No. They would have made it a younger date because they're handling it in the Middle Ages. If you took some of your textile from the 1st century, and you put your own, sweaty palms all over it, then you would have mixed the 1st century stuff with some 20th century stuff, and you would have shifted the date towards the 20th century and made it appear younger.
Yes, that's what I'm saying.
But it didn't. If you look at my little diagram there, the contamination makes it appear older. The more contamination you put on, the older the date was found to be. And that would be a surprise.
Yeah, that doesn't make sense to me, but anyway, okay.
No, it's the wrong way round. If you picked up your piece of cloth, handled it as much as you like, I don't know, rubbed it with candle wax, whatever you like, and then tested it and found it came from the 4th century BC, you'd be astonished.
Yes.
It should be moved so that it's that the more contamination, the younger it is. But as we can see here, in fact, the more contamination, the older it appears.
I didn't see that in your diagram, but anyway, okay.
Yeah. Well, look at can you see the little chart with the green bands? One that says Oxford Old, Zurich Mid, and Arizona Young.
Yeah.
That is the actual order in which the samples were taken off the shroud, and they correspond to the 3 small boxes which I've outlined in blue on the left-hand side. And
Okay.
as you can see,
I understand that.
yeah.
Oh, I understand that. What I don't understand is your dating and how, because you're dating it to the medieval period, perhaps, correct?
Yeah. No. So I'm saying that the contamination makes absolutely no difference at all. It was cleared off. For the time being, it was removed. The contamination has not had an effect. And in fact, I mean, obviously, if you're dating your scrolls or something like that, if you'd handled those scrolls quite massively and rubbed some 20th century muck into them,
They date to the current period.
No. It would have dated maybe to the 3rd century AD. You'd never have been able to contaminate it enough to shift it by 1,000 years.
Oh, I understand, not that far, but it does contaminate it, so it does shift it off because we have problems with all of our dating that we see in the lab, and some of it does get contaminated and pushes our dates off.
Yeah, but by how much?
Well, that's always the big question, and that's a variable that we can't determine.
On the contrary, we can determine it. We can find out by as much contamination. We know how much contamination is needed to shift a date by a very fixed amount. We can say how much 15th century contamination would be needed to turn a 1st century date into a 12th century date, and we can say how much 20th century contamination would be needed. Obviously, 20th century contamination would be, as it were, much more effective because there would be so much more radiocarbon in it. But if we use, as Joe Marino is suggesting, 16th century contamination, then nearly 3/4 of the sample would have to be contamination. And you would have noticed on your samples that you took out of your jars, if 3/4 of it was modern contamination.
Yeah, but it's handled. It's been handled and contaminated throughout the years, and so there's multiple layers.
Not so much that 3/4 of it was contamination, and not so much that any contamination would make it appear older rather than younger.
I still don't follow the logic there, but anyway, okay, continue.
Let me ask one more thing before you.
Yeah.
You kind of above my pay grade on all this a little bit. I'm going to rewind it later on. Hey, what David is saying, this contamination, I see what you mean by it doesn't affect it affects it by a percentage. Is that percentage calculated into the plus and minus? Like you say, it's 1350 plus or minus 50 years. Is that part of the calculation of that or no?
Yes, it would have been included.
Okay. All right.
But I think, yes.
You're saying they calibrated it for contamination?
Yes.
Okay.
But they were aware that there was going to be a tiny bit. That's why there's so many reasons why carbon dating isn't precise, and that's why.
Yeah, we rarely take it as sort of the last. We go to our pottery because we can date that more accurately with seals and pottery rather than the carbon dating, because it's all over the map. Every time we send a sample in, it can come from the same locus, the same spot. We don't know. Short-lived, long-lived, whether it's a tree or whether it's seeds or whether it's, the tree could have been cut down, 100 years ago. And so the dating thing for me with carbon is not accurate in my mind.
However,
as a scientist.
Well, no, I mean, we're well aware of all the various things that happen when carbon is taken up from the atmosphere. We know the variations in the atmosphere. We know how carbon is taken up. The proportions of radiocarbon are taken up differently by different species of plant. For example, some plants take up more carbon-14 than others in proportion to the amount of carbon-12, and so on. And this is known and it is calibrated for. But the bottom line here is that the picture on the left shows that the Oxford sample was more contaminated than the Zurich sample, than the Arizona sample. And the graph in the middle, chart in the middle, shows that the more contamination, the older the shroud appears. And that is directly contradictory to any possibility that contamination could have made the shroud appear younger than it really is. So that's when you go back and listen to it, you'll go, oh yes, that's the point. When I first made this point back in 2015 on a wonderful blog site which was called shroudstory.com, there was an enormous backlash as people went, no, I don't understand. What do you mean? We've proved that there's a 99% of this and that and the other. And eventually they realized that the contamination cannot be a factor in the in making the radiocarbon date, in changing it, so that it's much more likely from those grounds to be as far as we can tell, not sufficiently contaminated to shift the date from being as accurate as the labs were. In other words, it's medieval. Now, the next three pictures, which I put in simply because everyone who discusses the radiocarbon dating gets a few stills and pictures. And these three, I think, have never been shown before. So they're taken from the video which was made by or under the direction of Giovanni Ricci. And they show the samples have been put into Petri dishes on the left-hand side. The chap in the lab coat is Giovanni Ricci di Numana, who was responsible for the management of the whole radiocarbon dating procedure. He then took that tray with the samples away from the shroud itself and most of the observers into a side room where you can see Cardinal Balestrero on the right-hand side in his cardinal uniform. Ricci just about to put the tray down in front of him. Luigi Gonella, the scientific advisor to the Cardinal, on the left-hand side, and Michael Tite, the British Museum supervisor, between them, watching. And then on the right-hand side, we can see that the Cardinal is looking at the tray, and in front of him, there are three stainless steel containers with little screw caps, and in front of them, boxes with in which to put the stainless steel containers so that they can take them back to the labs. At the top is the arrangement that the Cardinal could see. And as you can see, the Petri dishes slightly overlapped the tray that they were on. And you can see that basically up in the right-hand side, top left-hand side, we've got S1, S2, and S3, which were the shroud samples. And then at the bottom, along the bottom, are 1, 1, 2, and 1, 3, which were one of the control samples. And then on the right-hand side, we've got 2, 1, 2, 2, and 2, 3, which were the other control sample. Now, as you know, Michael Tite couldn't find a medieval sample close enough that anyone would allow them to chop bits off. So he had written to Evian, Jacques Evian in France, to say, have you got a medieval sample that we could use? And Jacques Evian had gone along to a cathedral in southern France, whose name escapes me, and found a bit from the Cope of St. Louis, which was exactly contemporaneous. So he wrote back to Michael Tite, yes, I've got a bit of medieval shroud, I'll bring it with me. Unfortunately, there was a postal strike, so Michael Tite never got that message. So when Gabriel Vial turned up from France, he said, I've got the sample that you wanted. And they went, we didn't think you were coming. So we've already got our 2 samples, thanks. So as to make the whole exercise not a complete exercise in futility, the third reference sample, which we might call 3, 1, 3, 2, and 3, 3, they were put into envelopes and just given to the labs separately. They weren't included with this distribution of the shroud and the two well-known control samples. That was just a bit of a sideline. Right, there we go. That's about as much as I wanted to say that I hadn't, because that most of that what I've just shown you is a new way of showing some old stuff rather than the same old stuff regurgitated over and over again.
All right. Well, I mean, I'm not an expert in carbon dating. All I'll say is just that whole thing has just muddied the water for me.
Well,
So anyway, it didn't help me. It didn't help straighten things out for me because
yeah, but do you work with carbon dating experts? Show them that little section of this video and say, what do you make of it? And see what they say.
yeah.
I mean,
Well,
I've
the issue for me is contamination is contamination. So we don't test anything that's been contaminated. We throw it away and we try to get one that is uncontaminated from a sealed locust, handled so it's not contaminated, short-lived. So we want seeds, something like that, because we know the year that it was harvested, rather than a tree that could live for 4,500 years or whatever. So I'm looking at it from the archaeologist's perspective and the way we handle it. And they may have handled it correctly, but I'm just saying for us, contamination is significant and it's a red flag for us. And so, like I said, I would throw that away. So for me, that's a non-starter, and that's not even debatable or significant for me as a scientist and archaeologist.
Yeah, because you're in a position to throw it away, whereas a relic like the shroud, we're not really.
But I'm talking about the use of carbon dating.
Carbon dating is used a lot for, I should say, archaeological sites where you can find seeds and stuff like that. But of course, it's also used for.
We calibrate that with the pottery that's found at the same level. So that's how we do. We calibrate it that way rather than just waiting for.
But a few years after the shroud was dated, for example, they found in Assisi some clothes belonging to St. Francis of Assisi, and they wanted to know if they were fakes or whether they were, or perhaps whether they were misattributed, and so they were carbon dated, and of course, they're not so much holy relics, but I suppose Francis of Assisi they count as second-class relics or something. So they radiocarbon dated them, and they found that some of them were exactly contemporary of St. Francis and some of them weren't. But again, the problem of contamination was still there because these clothes had been shoveled around from place to place for the last 500 years. And then there's another very famous example where somebody dug up a Viking horn in Newfoundland, I think, something like that.
My part of the woods.
Oh, well, there you go. You must look it up. I could probably send you a reference if I could find it. But it was marvelous because it was a Viking horn, I think made of bone, or made of actually sort of cow horn. And it was used to establish help to establish the fact that the Vikings had arrived in Canada long before Christopher Columbus had arrived in the Caribbean.
Right.
And that was carbon dated and found to date from the 1950s. And there was an enormous fuss about it, and people said, this just goes to show that radiocarbon dating is completely wrong, until the bloke who had actually carved the Viking runes on it owned up and said, it was me. I just did it for fun. So there's a certain amount of that goes on.
Well, exactly. That's why I say we have to find the material that we're going to be doing carbon dating. We have to find it in a clean locust, uncontaminated, as far as we know, and test multiple samples from the area, not just one, because our dates come back all over the place.
All over the place. They don't come out, 2,000 years apart. I mean, they might come out 100 years.
Sometimes they do. Depending on how badly the sample's been contaminated and where we took it from. That's all I'm saying is that I don't put a lot of stock in my carbon dating. That's my secondary dating. The primary for us is pottery. That's all.
Right. Well, unfortunately, there's not a lot of pottery on the shroud, so we have to make
But is there other things that can be tested on it?
Yeah. Not from a dating point of view, although we could mention some of the more peculiar dating ideas that people have come up with. But I will say that the current most popular authenticist view of the shroud is that there's absolutely nothing wrong with the carbon dating, that it was all exactly, the proportion of radiocarbon was exactly as discovered, but that during the resurrection of Christ, the body had given off neutrons which had crashed into the carbon of the linen cloth and increased its radiocarbon content to the effect that it now looks, it genuinely looks as if it is whatever, 13th century and not 1st century. There's absolutely no evidence for that. But Bob Rucker, who was the person who's proposed it, has pointed out that if by the time the radioactivity reached Jesus's toes, near which the radiocarbon sample comes from, it would be quite severely attenuated, so that the parts of the shroud over his chest and on the small of his back and over his head, they would have so much extra radiocarbon that they would actually be radioactive today. And if they were tested to find out what proportion of radiocarbon they had compared to modern, it would come to something like 1.5%, 50% more than the atmosphere has. So technically, that would date the shroud to way into the 23rd century. So if that was found to occur, that would substantiate his hypothesis. It hasn't been found to occur yet, and I don't think it ever will be. But he comes up with a hypothesis which is fits the data and which is testable. So
we say in archaeology that they're arguing from silence. So we don't. The lack of evidence is no proof of. So
yes, it could have been produced. Somebody else pointed out that caves, in particular, are well-known portals by which aliens arrive on the Earth, and therefore it could be that the shroud was contaminated by aliens as they went through the sepulchre on their way around Israel. This is also not a hypothesis to which I adhere.
No, well, just more proof of why I haven't gone down the rabbit hole.
There's a lot of it about.
A lot of hypotheses, a lot of variables, a lot of unknowns. That anyway, I'm finding it very interesting. So
okay, well, we'll crack on. If you thought that was interesting, we get some really interesting maths now.
Hey, David, I got to mention that this is Biblical Archaeology from the Ground Down, sponsored by Bible Interact.
Right.
So, and we also have our second sponsor, the Museum of Archaeological and Biblical History, and we thank both of them. Right now, we are up to 365,000 subscribers. We thank each and every one of you for your viewer support and financial support. Thank you very much.
Good.
You know
George,
what?
you have any other questions? Or?
No, I'm done. Oh, if I was going to do one more question, even though we had the ending an hour ago, it's on blood typing. In the symposium where they're having the discussion, part of it, of course, is going to be the blood typing. I think they mentioned AB negative, and they said the blood type being AB negative mentions the napkin of the face, or that was around the face also, that was AB negative. Now, one thing also that we learned going back to those 30 years ago days in the military, gave away my age a little bit there, David, was when things get boring, they teach us a little forensic. And of course, sometimes we had to type blood. Some people think you're AB, I'm AB. That's not true, because there's what we call factors. There's RH factors, and we have to have the right RH factor. And then also has to be antigen, and there could be positive or negative antigen. And those all have to be tested to make sure that that blood does not coagulate or that be rejected and you have bad reactions in the person receiving the blood. Now, let's say that in forensic, they're going to test for blood to say that if this individual was at this location and there's blood, does that match the blood of the individual? But on that item being tested, that was just found, it was just located. However, the event happened 2 years ago. What about the blood? antigens being carbon-based degenerate. So in other words, they might all test as negative. You're looking for an antigen, it's not there anymore. And the older it is, the more it's going to disappear. Fair enough? So that means you're testing the shroud and you're testing, I don't want to be rude, the napkin, the Mendelian, I believe. And it says, well, it's negative. In negative antigens, they all match. Well, guess what? There aren't going to be any antigens there anyway.
No, yeah. If you test, there are two ways of testing blood. Two simple ways. The first is to test the red blood cells themselves, which have antigens sticking out of them, and the second way is to test the plasma in which the blood is floating, which has antibodies. And if you have A-type antigens sticking out of the corpuscles, then you have anti-B antibodies in the blood, yeah? Mm-hmm. Because you don't want B to clash with your A-type corpuscles. But right. If you have AB blood, then the corpuscles have both A and B attached to them, so you have no antibodies in the serum. So if you have a test for serum, then you could test AB blood or jello or red paint, and it would all test negative because none of them have any antibodies in them.
There you go.
Similarly, as you're right, the corpuscles themselves, the antibodies fall off, they degenerate. And so if you tested that, you might find that there was nothing on the corpuscles at all. So you might think that was blood type O, but more likely you would test some of the little antibodies themselves, which are also found in bacteria. So the leading shroud investigator of this is a chap called Kelly Kearse, who's published a great deal of papers, which he studies blood himself. He gets hold of gallons of it, and he's done lots and lots of investigations. And at the last Shroud conference in St. Louis last year, he delivered a paper saying we can't say anything about the identity of the blood on the shroud. We can't even tell if it's human, let alone what blood type it is.
Fair enough. Yeah. Well, once again, I think in the symposium, actually, your name came up as far as being a witness that there was blood. I don't know, AB blood or something. So
I think there probably is blood, but I'm certainly not saying what kind it is.
There you go. Yeah.
Well,
I understand.
Then we can't even say whose it is with any kind of certainty because we don't know. So it could be anybody's blood if that's the case. But
well, there's one thing which is quite interesting, which is another theological dispute in the Middle Ages, was that when Jesus was resurrected, everything about him was resurrected. So there couldn't be blood on the shroud because that was resurrected.
One of those how many angels can dance on the head of a pin argument.
Part of it was that there could not possibly be anything left of Jesus on the shroud, on anywhere, because when he was resurrected, all of him was resurrected.
Well, I don't think interesting. There's in Jewish burial customs, if a body has been traumatized, where there's blood on cloth or blood on items that have in contact with that individual, the body was not washed because that becomes part of that sacred individual and buried with him or her.
Now they say that.
Huh?
I don't think it's true.
That is true. You could Google it or AI it or whatever.
I have done, and I don't think it's true. And I'll tell you why I don't think it's true. I have seen film of parts of bodies being rescued from the streets of Jerusalem after terrorist bombs, and sure enough, you've got all these, the black-hatted and the hair down in tendrils rushing around, dabbing cloths all over the blood, so that they can collect as much of the blood as possible, and it's buried with the body parts.
Yes.
And you can do that if you've got a leg and it's all covered with blood. You can wash it off, you wipe it off, but you keep the cloth.
Keep the cloth.
It doesn't have to stay on the body. You can, I mean, if the body's a real mess and the parents want to come and see it, you clean all the blood off. You don't throw it away. You keep it because it's part of the body, but it doesn't have to stay covering the body.
Oh, I see what you're saying. Well, this article I read made it seem like the way I read it.
Oh, it always does. It always does. But I have yet to be corrected on that.
No, well,
I mean, I don't. There must be
easy
some
enough because people can just AI it and read it however and translate it how they want.
But what we want is
customs of burial. That's all.
What we want is an Israeli undertaker who's used to dealing with people who've been smashed up in a car crash and course, they're taken in, they're laid out. Their parents and their wives and their family want to come and see them. They've got their shroud on, and you can see the face. You're not going to tell me that he's going to be left with bits of blood and glass and stuff all over him. I don't think so.
You can't trust AI. It'll just tell you, takes consensus of the misinformation out there and feed you that. So you got to do your own research, primary sources you've done. So I would encourage our audience to do their own research. Look up the primary sources. Don't Google it, because it'll tell you almost anything. Really appreciated your research today, Hugh, and presenting your detailed scientific analysis and forensics of it rather than just hearsay. So appreciate that a lot.
Thank you. Thank you.
George, do you want to take us out?
Yeah, sure. I'd like to thank everybody for being with us on this study on the Shroud of Turin. So we could get both sides to the story, and this has been very, very interesting. And once again, thanks for your support. Like we are closing in on 366 subscribers. Mr. Farey, thank you very much for your time and effort. This has been fantastic and definitely a resource for our podcast. And I really, really appreciate your time.
I'll tell you one thing, and that is, if anybody has questions, if they write them in the comments, I always respond to them, unless they're abusive. But, you know, sometimes people write questions and the people in the podcast don't look at them. I always do. So if you've got questions, people, you let me know and I'll reply.
And we'll get those links from you and we'll post them in, at the bottom of our podcast so that others can get your websites where they can get research and so on.
Pleasure.
Once again, thanks very much, Hugh, for your time, your effort, and your research on that. Much appreciated.
Thank you.
Right. Everybody have a great day.
Okay.
I'm going to pause this right quick.
Okay.